Hello, my name is Evie, and I'm a second-year engineering student studying creative technology and design at the University of Colorado, Boulder. Today's lesson is all about measurement and how engineers use it, and I have HelperBot here, who loves to measure things, to help out. Are you familiar with pounds, feet, inches, and gallons? What about meters, grams, and liters? These are all valid methods of measuring things, from length and distance to volume, mass, and more. Engineers often use measurement units like these to measure things for their projects. Today, we're going to dive into what terms we can use to measure things. There are two main measurement systems that most people use, the imperial system and the metric system. Engineers and scientists often use the metric system instead of the imperial system when measuring things for their projects and inventions. The metric system consists of meters, grams, and liters. The imperial system consists of pounds, feet, inches, and gallons. The imperial system is mostly used in the United States of America, while the metric system is typically used everywhere else in the world. The USA often uses the metric system when working with engineers and scientists, though, as it's easier when everyone can use the same measurement system, no matter where they're from. It's pretty important that we use the same measurement system to help make sure everything we build together is accurate. You wouldn't want to make a cake with the wrong measurements because of a system mix-up. It might not turn out to be a cake if you did. The metric system tends to use prefixes to show a much larger or smaller amount, so the final number we get isn't as big or small. We have the base measurement of meters, grams, and liters, and each one of those represents a single unit. Then we have premixes like mega and kilo, or centi and milli. Here's a table to show you all the prefixes, their abbreviations, and how many units there are. I'll leave it up on screen for a few moments. Feel free to pause if you'd like to read through all of them. If you're more familiar with the imperial system rather than the metric system, here's a table of all the different conversions. For example, 1 foot is 0.305 meters, and 1 inch is 2.54 centimeters. I'll leave this table up on screen for a few moments as well. Feel free to pause again if you'd like to read through them all. You can measure all sorts of things now that you know these measurement terms and units. Distance or length can be measured with any type of meters. For example, you might measure the length of your hand by using centimeters. Meanwhile, if you were to measure the distance of the sun from the Earth, you'd measure it in something much bigger, like kilometers or gigameters. We can also measure mass, how much matter something has, by using grams. For example, a couple of peas may only be a few grams. Meanwhile, a stack of heavy books could be measured with kilograms instead. And finally, we can measure the volume of a liquid or space with liters. For example, a jug of milk may be a liter or two, while some liquid in a test tube would be measured in milliliters. The possibilities are endless. Practically anything physical can be measured in some way, shape, or form, and now you have the knowledge to measure them all. Estimating measurements is a pretty useful ability as well. It's good to be able to know an estimate of how much something may measure just by looking at it, as accuracy isn't all that important in day-to-day life. For example, I could look at HB and guess they're about a foot wide, or around 0.305 meters. Of course, it's important to be accurate as well, especially as engineers. You wouldn't want to build something by just guessing measurements when the whole build is very precise. Even small measurement mistakes can have big consequences. Imagine if a rocket was built with the wrong size fuel tank. Astronauts might not make it back to Earth. That's why accuracy and precision are so important in engineering. So, once you have a guess of your measurement, it's good to measure it accurately as well. If I measure HB with a ruler, I learned that they're actually 1.5 feet wide, or 0.46 meters wide. That's a pretty significant difference, and it could really matter in engineering. Engineers use many different methods of measurement, as we have seen. It all depends on what they're measuring, and what they're trying to achieve in the end. After all, measuring things is one of the building blocks of STEM. Engineers have used it to build rocket ships, and scientists have used it to create cures and vaccines. Measurement is a wonderful tool for you to use. I encourage you to start measuring things you see in your life, like how wide your bed is or how much your pillow weighs. It's a great skill to have, especially for future engineers and scientists. Anyways, that's all for today. Thanks for watching, and we'll see you next time. Check out the full lesson on the TeachEngineering website. Then, check your knowledge of measurement vocabulary by comparing your estimations of length and distance to the values you measure and exploring variables while testing and improving Mint mobiles, and to give an inch, take a foot.